Hi, welcome to this instructional video of the UTEST motorized charpy pendulum, which has a code of UTCI-0450. Let's just start with the general basic elements of this charpy pendulum. It has a body block inside, which bears and carries the hammer. And it has a control unit on it. It has a control screen, actually, touch screen used on it, and it has a USB port mounted on it. And on this screen, it has an emergency stop here. Now let's take a look at the back side of this device. Here we have an electric motor drive mounted on the driving axis over here, and on this part we have a on and open start and stop button over here, and it has an Ethernet connection port over here for the computer connection. It has a reed switch, which is the safety switch on the door, on the small door of this cabinet, and it has an encoder connection over here, which gathers the encoder data, and it has a hammer holder, the hammer lock system power cables over here. Now we have opened the door of the safety cabinet, and let's inspect the main features of it one by one. As you can see, we have a control unit on the door. And we have a hammer locking system over here, and we have a hammer itself, which does the job actually, and we have an anvil and the electric motor drive. These are the main parts of the charpy pendulum. Now let's start with the anvil. The radius tips, the angles of itself. The main geometry is designed and manufactured according to the standards. And the hammer over here has 16.13 kilograms of weight, and this weight, this mass, has a center of mass of 508 millimeters away from the axis of rotation, which is around here. And on the hammer we have a locking knot over here. And we have a hammer locking system over here. Whenever it is in the home position, it will have a 150 degrees of fall angle initially at home position. We use the electric motor drive to rotate the hammer to the home position or any other desired angle value. Now let's take a close look of the hammer locking system, of how does it work. Now I'm going to send the hammer to the home position by using the control screen. Now the hammer is rising, and whenever this knot closes to the locking system over here, the lock will automatically rise and open to let the nut inside here. Let's see. Yes, now it's in the home position and gripping. Now I'm going to release it. And after the hit is completed, it automatically rises to the home position again. Now, in order to see the screen and inspect how does it work, let's just power up the machine by using the start button over here. In the main screen, it just makes a booting operation. And here comes the UTEST screen. You have to just touch to pass this screen, as you can see, like this. This is the main test menu of the device. Now, let's start with the setting menu over here. Now we have 4 options on the top. The first one is the home button. Whenever we press this button, this hammer will go and rise to the 150 degrees, which is home position, and just rests over there. In the manual mode, if we want to drop it, we have to come back to the previous test screen and press the play button, which will be do it in a minute. Let's see how does it work. Yes, it's in the home position, and the hammer lock is just locked onto the hammer locking knot, which is mounted on the hammer over here. Now, the second button is the hammer release button. Please do not confuse this one with the play button over here. This is for the test initiation, and this is for just to release the hammer. I mean, imagine that there's no specimen on the anvils, and you just want to drop the hammer and control it and do it whatever you want to do. It just releases the hammer, and you cannot get any energy information in this mode. It's just, as I said, manual control of releasing the hammer. And whenever I press this square button, which is the stop button, it will just hold the hammer like this. Now, whenever if I press this home button again, it will just rise up again and go into the home position. Now our hammer is raised up and it's in the home position again, and the hammer lock is locked onto the locking knob. And now there's a fourth button, which is a purple one, and which has a wrench and hammer sign on it. Let me just leave it to the end of this instruction video because it's a little bit complicated one. Now there are some other buttons and functions over here. Let me just move on with them. Here you can see a button with O, actually it says 0, and writes angle. Now it shows us the angle as in the live formation. This is, now the angle is 150.2 degrees. The 0.2 degree is the gap between the hammer knob and the hammer locking system. Whenever the gripping system releases the hammer, as I said, the hammer will be rested on the locking system, and the 0.2 will not be observed anymore, and it will be exactly 100.0 degrees. Now, let me just release to explain the function of this button. I'm just using the free fall button over here, and the hammer is used, and I'm just grabbing it nearly close to the 0 point, and I'm just giving it I'm just releasing it again and opening the door. Please be careful over here because the hammer is a little bit rather heavy, but it's in this position, you can just use your hand to stop it. Now the hammer is free, and all work is done on it. It's just the gravitational acceleration, and so it's in the most vertical formation of itself. Now it's exactly vertical to the ground. The gripping system is open. The hammer is free to move any direction, but it's on the rest. Now you can see the angle over here, 0.0. And it goes to the 0 and 0 elements. Whenever you initiate the machine, whenever you open the machine from the beginning, it is strongly recommended, actually it's necessary to release the hammer in this situation, in this position, which is exactly vertical. And if there is any deflection of this angle, for example, in this position, if it says, let's say 5 degrees, you have to push this button to make it 0. And whenever you push this button, it will be, the initial degree will be reset as 0, and all the angle readings will be according to this initial position. As you can see, whenever I press it, the gripping system just grips it and resets the initial degree as 0. Now, other button over here, there is a charpy pendulum symbol on it, and it writes as the target angle. This is just the functional usage, for the functional usage of this hammer. For example, if let's say I want to be a little bit experimental and I want my hammer to be on the 30 degrees from the vertical, I press the here, let me show this one again. There is a 0 degree showing up because it's initially set as 0. Whenever I press the number, target angle number on it, there's a screen comes up. Actually, it's a number pad. Let's say I enter 30 degrees or 30.5 degrees, 40.5 degrees. It all depends on you. And I press the enter. Now my target angle is 30 degrees. Whenever I press this symbol, the hammer is going to be raised just 30 degrees and wait over there. Yes. Now, as you can see, it's 30.01. I mean, it's nearly exactly 30 degrees. For example, if I want to move 120 degrees, I just enter here 120 and send it to the 120 by pressing this symbol icon on the touchpad. The vice versa is also possible. For example, if I want my hammer to be on the minus 40 degree in this side, I just enter here minus 40 degree and enter, and I just press this button again to send it to the minus 40 degree. As you can see, it's now at minus 40 degree. The uppermost boundaries are minus 150 degrees and 150 degrees on this side. Please do not write any number which is greater than 150 because these are the limits of our device. Now I'm just putting my hammer to free fall again by using the button. And I'm just stopping it with my hand. Alright. Now there is a green button over here, and it actually just turns green and red. This is the set button of the control when we are applying the test. For example, in the manual mode, whenever it's green and vice as the manual, it's just waiting for our orders. What does it mean? Whenever it's in the manual mode, we come to the previous page over here. There's a play button on the upper right corner of the screen. For example, let me just first send it to the home position again. Yes. Now it's in the home position and it's ready for the test to be completed. Whenever it is in the menu selection, then we go to the previous page, which is the main test screen. Whenever I press this play button, the test will be initiated manually. I mean, with my command. I mean, let's see if whenever I press this button, the test has been initiated, and the energy absorbed is displayed on this capital numbers over here, which is now is 0.06, which is really small value because there's no specimen over here, and it just redirects itself to the home position again. Whenever it gets into the home position, I can put another specimen and press the play button and make another test on the second sample. Yes. Now, let me just talk about the main screen, test screen over here. Here we can observe the specimen number, which writes over here 30. You can just change it 1 or second or whatever it is. It will just follow the next specimens 1, 2, and 3, and so on. Just in the middle of the screen, there is an energy absorbed in joules, displayed as a capital letters in order to be observed better. And there's another line, another parameter over here which shows us the angle. As I said, it's the live angle, and it is 150.2 at the moment. And you can observe the hammer velocity in meters per second over here. When it is active, you can observe the hammer velocity as well. And here we can see the potential energy as 150.1. Whenever it, as I said, whenever it rests on the hammer lock, this angle will point to, 150.2 will be 100 degrees, and the joule will be exactly 150 joules. Now, as you can see over here, the second line from the bottom is angle of fall. It's just rises 150 over here. It just starts from the fall angle from 150, and you can see on the second line the rise angle. After hitting the specimen, the uppermost degree that the hammer rises. And on the very bottom left right corner, there's two buttons. The blue one is the settings menu, which I explained previously, and the pink one shows us the test results. The first specimen, second specimen, and goes so on. And you can see over here, it can holds the data of 50 tests in its memory. Whenever this number of tests has been reached, whenever, let's say, we come to the 15th specimen, it will just gives us a warning in a yellow icon that the memory is reached. And you have to put a USB drive over here and just put those data to the USB stick, and just you can clear the memory. yes, here. Now, the very last thing over here, as I said, as you can remember, I just leave this fourth button to the very end. It is a little bit about the working principles of this device. Now, it's actually, as you can see, it's password protected. Whenever you see the dashed lines on the numbers over here, it means that it's locked. When you enter the password, it will be unlocked and you can change them. But it's not recommended because these are calibrated and arranged in a really sensitive manner. Now, the first one is the initial angle. You can choose another initial angle. Let me just input the password is 981985. Now, as you can see, the dash lines are cleared, and these are the menu is open. For example, I can enter here 140 degrees, which means that the hammer is going to be will be fall from 140 degrees. But since it's initially 150.3 degrees, it will be stay like that. And the second one is the length of the pendulum. This is the complete length of the pendulum from the rotation axis to the very end of the hammer. And the third line is the distance between the center of gravity of the pendulum and the rotation axis, which, as I said earlier, is 508 millimeters, which makes 0.508 meters here. It will be in units of meters. And the mass of the pendulum over here, if you change another hammer and try to use another hammer over here, you can write this new mass of the hammer over here. And the last thing, when I push this button, it will be just go to the previous page. And the very last thing over here is the direct verification button. As you can see, this button. This direct verification method is described in most of the standards. It's basically goes like this. It will just it releases the hammer from the initial position and makes 10 half spins and just records the data and get the average energy loss in angle or in joules over here. Whenever I press this button, it will record all these 10 half swings and gives us the average loss of the system in joules. Let me demonstrate it. As you can see, it will just complete 10 half swing of cycles. And numbers are changing, as you can see. And after finishing these 10 half swings, it will automatically stop the hammer. And as you can see, the loss per cycle, I mean the average of these 10 half swings is 0.7 joules, which is really nearly the 0.5% of the nominal energy, which is 150 joules. Yeah. Now I'm turning to the main page again, and there's another thing that we have to say. Whenever I press this manual button to automatic one, and whenever I send it to the home position, the whole system is going to work automatically by command of this door. There's a metal sensor over here which recognizes the motion of the door. Whenever I close the door, I just put the hammer to the home position, and then I'm just going to replace a specimen. And whenever I close this door, the test will be initiated automatically. And I can continue very fastly by using this automatic mode. Imagine that I put a specimen over here and I'm in this test screen again and I'm just closing the door. Test initiated. Whenever it is going to the home position again, I can open the door. And whenever the handle is removed from the annual area, I can put another specimen over here and close the door and wait for the test initiated automatically. And the second specimen has been destroyed. And it just goes to the home position again. These all goes in the automatic cycles. Home position, closing the door, putting the specimen, closing the door, hitting this, the next specimen, and goes like this. I mean, these are all the features that this motorized charpy pendulum of UTEST has on the screen. And now we are going to make a test with the real specimen. Now I have a standard specimen in my hands, which has serial numbers on it, and it's 10 by 10 in width and height, and it has 40 millimeters in the length, and it has a V notch over here, which is 2 millimeters of depth. And now I'm going to hit this specimen with the charpy pendulum. Now it's in a manual mode, and let's just make it stay like that. And I'm going to send it to the home position. Now it's in home position, and since it is in the manual mode, it's free from the motion of the door. It will not recognize, and it's just waiting my command on the screen to play this button over here. Let me show you another thing about this charpy pendulum. In this site, where the specimen will be hit and thrown over here, there's a gap, an opening over here, as you can see. You can put the UTEST broken sample gathering tray over here to just collect these samples. After the specimen is hit, it will be just hit this side and will just slide to this opening, and you can collect the specimens without opening the whole doors and systems again. You can just remove these broken specimens. Now let me insert this specimen to the end. You can use both specimen centering slots over here. Now, as you can see, it cannot be moved freely in any other direction, and also you can use the specimen centering scissors. But just for the demonstration, it's almost centered over here and ready to be for the impact test. Since it's waiting my command, it will not recognize the motion of the door. I'm just closing it for the safety reasons. And I'm on the test screen over here, which writes specimen number, energy absorbed, and so on, as you can just explain. And whenever I press this button, it will just release and hit the specimen and shows the impact energy, energy absorbed by the specimen in here. Let's start. Yes. As you can see, the specimen is hit and the hammer goes to the home position again. And as you can see, the broken specimen is just spit out from this opening to the outside, which there will be a tray. As you can see, it's a perfect hit. There's no scratches, no any deformations on this end, which says that the all energy goes to the braking, initiating this crack over here, and there's no any other energy absorbed by the specimen. This is just visual inspection of the specimen. Now, as you can see, the energy absorbed value over here is 9.967, which is nearly 10 joules. And that's it. That's how the UTEST motorized charpy pendulum works. Thank you for your attention.